Hello, I'm Anthony. Today I'm going to give you an introduction to the Process Logical Editor in Cubase. This can be one of the more intimidating aspects of the application and something that beginners might shy away from because it looks really scary and number crunchy. But actually it can be a really inspiring kind of fountain of creativity. I use the Process Logical Editor in a creative way to help me when I'm writing music. Hopefully I'll be able to show you some examples of that today. If you enjoyed this video and you'd like to help support my channel, check out the Patreon and YouTube channel member links below. It's a fantastic way to do it. Before we get underway with a demonstration of the editor itself, just a quick talk about final locations. Since Cubase 12, the logical editor presets are stored in two different locations. The factory presets are stored in a different place to the user presets, and you can see that they're split at the top level. There's nothing you can do about this. Cubase is going to look at both of these locations. This didn't used to be the case. And I think the idea is that they want to steer you away from using this factory location. It's called the roaming folder. And now user presets are stored in your documents folder instead. So I'll show you each of these locations just so that you know what's going on and where everything is. So in the factory presets, you can see we've got 11 folders here, starting with all event types. I'll find that on my system. And here it is. Here's the logical editor folder. It's in this very long path that basically hangs off your app data. This is a PC view, obviously. There will be a Mac equivalent, but I work on a PC. You see it's inside the roaming folder, Steinberg, Cubase, presets, logical edit. So you've got to drill quite a long way down to find all of this stuff. But there are those 11 folders. As I say, from Cubase 12 onwards, your user presets are now stored in a different location. And there's even a button to say show user presets location. If I click that, here they are inside my documents folder, Steinberg, Cubase, user presets, logical edit. So these are the ones that I've manually configured. Now a lot of this stuff I've actually dragged across from the Steinberg default presets, things that I think are particularly useful. So I almost exclusively use the user folders. I only keep the factory stuff if I'm absolutely desperate for an example of something that I'm trying to do and I don't have a working example in my own folder. And most of the examples I'm going to show you today are from this primary list because they're the ones I use the most often. I basically want to drop down into this thing. The moment I enter user presets, I want to see all of the stuff that I want to use. It's right there, as few clicks away as possible. And the first example we're going to look at today is one of the simplest, fixed velocity 100. I'm going to select that. Fixed velocity 100 literally does exactly that. Let's have a look at this piano line in the background, and you can see all of these different velocities. If I select all of those notes and click apply, it's just set all of those events to 100. Just undo that. We can have a look at what's going on. So the logical editor is a pattern matcher. It looks for a condition or a set of conditions, and if those conditions are met, it's going to perform some operation. We specify our condition in this top box. So in this particular example, this is the simplest example I could come up with. There's only one condition, that we're only going to operate on MIDI notes. Don't forget, you've got all sorts of MIDI events. You've got like modulation events from the modulation wheel, pitch bend events, aftertouch. They're all MIDI events and they can all be processed. And in this case, we're saying we only want to operate on notes. What are we going to do to those notes? Well, value 2 is one of those unfortunate holdovers from the MIDI protocol. Value 2 stores the MIDI event's velocity. So this action basically says set the note's velocity to a fixed value of exactly 100. So this is one of the barriers to entry of the Process Logical Editor. You do need to understand a little bit of MIDI, and this is one of the very few pieces of kind of hidden information that you've just got to learn, that value 2 of a MIDI note is the velocity. We have a look at the operations. You can see all the various different things that you can do. I'm not going to describe every one of these. We'll be here all day, and most of them are really intuitive. Learning how to use the logical editor is about finding examples of things that are close to what you want to do and then adapting it to your own purpose. I very rarely create a logical editor page from scratch. I'll generally start a template with something that's close to what I want to do and then edit it. So here we're setting to fixed value, and this could be anywhere between 0 and 127. Down at the bottom is a very important drop-down box. This word here that says transform, basically going to do that. It's going to change the MIDI event data from one thing to another. It's going to transform it. But you've got all of these other options as well. Select is a very common one, deselect as well. extract, you're going to see some examples of that today. So this is a transform operation. So when I click apply, that operation gets performed. Control Z, undo that. So we're up and running with our very first simple example. I'm going to keep things super simple just for now. Let's have a look at another example, and this one is in my transpose folder. I'll share my entire user presets folder with my channel members and patrons if you want to check that out. Here's transpose plus and minus 12. I mentioned these specifically because these were in a previous episode when we talked about keyboard shortcuts. These two are set up on my PC keyboard. I've recently taught myself these commands, basically just performed them over and over again until it was locked in my memory, and I do use them a lot now. Transpose up and down. So let's have a look at the transpose commands. Here we go. Type is equal to note. Value 1 of a MIDI note is its pitch. Every MIDI note has a number between 0 and 127 that defines what its pitch is. Here are those numbers. So for example, MIDI value 48 in the value 1 slot of a note equals C3. So what we're basically saying is add 12 semitones onto the note's pitch. Let's watch all of these. So we've got an A1 up to an E3. If I click apply, the entire thing just jumped up an octave. Let's undo that. And then I've got an equivalent transpose minus 12, which is a subtract operation. Here are all the different things that you can do. One of them is an add, one of them is a subtract. So we're easing our way into these mathematical processes. I've not done anything logically complex yet. Let's have a look at another straightforward one. Probably the most common operations I perform in the logical editor are velocity ceiling and velocity floor. This is where I want to constrain. If I've played something in live, sometimes I'll hit notes slightly too hard or too soft, and I basically want to bring them in a range so I never exceed this particular value or drop below this particular one, but I want to maintain some dynamics to the sound. So I'll set a ceiling, the highest value that the MIDI note can be, and the floor, which is the lowest. So here's my ceiling value. Let's break this one down. Once again, type is equal to note. We've already seen that. Now we have a new operator at the end. This Boolean operator is an AND. It can either be AND or. This is an AND. So the next condition also has to be met. Can you see that you've also got parentheses that you can wrap conditions around? So you can say this or this and put that in brackets, and this or this, which is also in brackets. So you can basically have subcommands. So the second condition here is a property value. The property that we're interested in can either be set or not set. And in this time, we're looking for a set selected. So you can see muted, selected. So the event must be selected. That's really handy if I want to operate on just zones of notes. So let's pick that range. We'll just perform the operation on those. Now we're saying that the velocity is bigger. All of these different conditions that we can set, this is a bigger one. And then we manually type in this number. So this is the MIDI value that the velocity needs to be bigger than in order for the condition to be met and some sort of operation to be performed. The operation that's going to be performed is that we're going to set it to a fixed value. So everything that's bigger than 60 is going to get set to exactly 60. Here we go, let's click apply. And now everything that was bigger than 60 has just been capped out at 60. This note down here is just less than 60. I wonder what it is. There you go, it's a 57. Let's undo that. And velocity floor is the other way around. This time we're looking for velocities less than 60. Set them to 60. Okay, hopefully your mental muscles are nice and warm now. Let's start extending ourselves. For our next example, I'm going to select this Rhodes piano line. We have a chord sequence. I'll play the chord sequence quickly. Here it sounds like this. And what I want to do is to create a 3-part harmony line that vocalists can sing over the top of that chord structure. So now I'm going to use the logical editor creatively. It's now going to be genuinely helping me to write music. I'll open the editor. I've actually got a keyboard shortcut set up for this, but it's in the MIDI logical editor setup. See, there's my keyboard shortcut. And now we're going to have a look at this function, extract lowest note from chord. So what this function does is to examine the selected MIDI part. Wherever there's more than one note playing simultaneously, it has to be a chord. Let me just open that. See, it says note number in chord. Wherever there's more than one note playing, it'll take that lowest note and it'll extract it out onto a brand new MIDI line. So I'm going to get a vocal line that's basically close harmony. So I'm keeping the intervals of the notes as close together as possible. And that's one of the kind of, generally speaking, the golden rules of harmony. So let's have a look at the function itself. Type is equal to note. We've seen that many times already. This is a new one, context variable. Context variable does take a little bit of wrapping your head around. Most of these things are fairly straightforward. We understand what position means or length. Context variable is literally that. It's actually going to examine the MIDI part and try to make some sort of logical sense out of it. And in this case, it's looking for the ordinal position of the number in chord. And if I open this curtain, it says lowest equals 0. So it's looking, parameter 2, this 0 here, is the ordinal position of any note where there's more than one note playing simultaneously. So at the beginning of the loop, G2 is going to satisfy that criterion. Then we'll hit this A2, and then the D3, the A2. All of those notes are individually going to be put onto their own MIDI part. Now in this case, the transform actions box is actually empty because there's no additional operation that needs to be performed. The action option in the drop-down box directly tells you exactly what to do. We're going to extract to track, so I don't need to specify any additional actions that are going to be performed. Now if I perform this action now, only the selected note will get extracted. This is an important thing to bear in mind. If you don't specify whether or not something has to be selected or not selected, by default it'll operate on just the selected notes. So if I perform this operation now, just A2 will disappear. That's not what I want. What I actually want to do is deselect all of the notes. So now it's going to operate on the entire MIDI part. Click apply. Now all of those low notes disappeared. Where did they go? They're now on their own brand new instrument track down at the bottom of the piece. Let's go back up to the Rhodes piano. I'm going to open the logical editor again. Remember I said I wanted a 3-part harmony, so I'm going to do it again. This time when I click apply, there are new low notes to be selected. And that's that done. Now, I want a 3-part harmony, but I'm looking at this part and I'm thinking, hang on a minute. If I perform that operation now, this poor old vocalist is just going to be singing A3 for the entire bar. That sounds pretty miserable. So now I'm going to use some common sense. I'm not going to extract the lowest note anymore. I want to do something a little bit more intelligent than that. I'm going to extract the second note from the chord. So we're still looking for chords. We're still looking for those places where we've got choices to play with. But now I'm going to extract the second note from chord. And the only change in the algorithm is that parameter 2 has changed from 0 to 1. Remember, 0 is the lowest note. So now we're looking for the second note in a chord. So now let's have a look at this cycle. At the beginning of the cycle, F#4 is going to meet the criterion. That's the second lowest note. But D4 also meets the condition because it overlaps A3, so that will get extracted, as will E4. In fact, most of these upper notes, if not all. Let's see what happens. And sure enough, all of those notes have been extracted. So here we've now got 3 independent harmony lines that our vocalists can sing, and there are no vocal acrobatics to be performed because all of the notes have been kept as close together as possible. I'll quickly dial in some choir sounds for these 3 parts and we'll hear what this sounds like. Okay, so I've dialed in some oohs and ahs for the 3 different harmony lines. Now let's play those just soloed. Don't want those long gaps, do we? Let's legato all of those. And I would probably want to stop about there. So if I handed those instructions to Pauline, my wife, who does all of my singing for me, she would be able to sing those 3 harmony lines over the top of this melody. It would be a lot of trouble for me to do that manually, but incredibly easy for the algorithm to do that in seconds. So for the next example, I'm going to use the drum beat. I'm going to do some processing on these hi-hats. Really simple drum beat. And that constant hi-hat, I want to do some interesting stuff with. I'm just going to have a bit of a play with it. The first thing that I'm going to do is grab some of the notes out of that hi-hat line and move them somewhere else. Let's open my logical editor. And this time I'm going to select every third note at pitch. Let's have a look at this one. So what I want it to do is to select every third note in the hi-hat line. Let's have a look at the algorithm. If I click apply at the moment, it won't do anything because it's actually set to the wrong note. Let's have a quick look at the algorithm. Type is equal to note, and here we go. Last event, the condition is every other event. Now, every other event doesn't mean every other event. It's basically like a sequence jumper. And we have this thing called an event counter, which says jump forwards 3 notes at a time. So it's actually every third event. This condition, every other event, plus the event counter of 3, does exactly that operation. It's going to select every third note. But the pitch is also important because I only want to operate on the hi-hat. The hi-hat's F#1. So I need to input F#1 here. No transform action, but there is a different option in the drop-down box. Now this is going to be a select. We're not changing the data. We're simply selecting some of the notes that we're going to manually edit. I'll click apply. And now you can see every third note's been selected. Let's move then down to the side stick. And now we've got a different drum beat. Kind of a nice syncopated feel to those side stick hits. Let's make them a bit louder. In fact, let's set a floor of 100. Too loud? Let's undo it again. I could set it to 90 and you get the point. Just jump back to our algorithm, F#1 again. Now we were actually quite lucky then. I'm only interested in this loop, this cycle bars 13 to 17, and it just so happens that the third event in that cycle is the one that got selected, but that's entirely at random. The algorithm's actually performing on the entire MIDI part, and all of these previous notes have also been thrown into the mixing pot, which means if I delete one of the notes from the bar preceding the one I'm interested in, now everything's going to get shifted forward a note, and whereas this note that I'm currently pointing at used to be the third note in the bar, now it's going to be the first note in the bar. So everything's now out of kilter. If I want to make sure that the operation only performs on a particular range in a MIDI part, I can do that. So I'm going to add a condition to this logical editor, and I'm actually going to permanently change this because I've decided that this is something that I want baked in to this algorithm permanently. So I'm going to select one of the operations in the target filter, and I'm going to insert a new condition. This is going to be a position sensitive condition, and I'm going to specify that the notes must exist inside the cycle markers. Now, whereas previously this was the operation that got executed from the algorithm, I'll deselect all of the notes, I'll click apply again, and now it's only interested in the cycle notes. See, none of the notes before bar 13 have been selected. That's actually a superior algorithm. I prefer this to the one that I used to have. In preparation for this video, I decided I needed to improve this algorithm. So now I'm going to save this preset. Save changes as preset. It pops up my user presets folder, and I'm going to overwrite this XML file here. And that's that changed permanently now. Every time I execute that command, I'm going to get just the events in the cycle markers. The last example I'm going to show you today is another operation on the hi-hats, slightly more complex this one. And this time I want to select notes on beat. So it's going to do exactly that. It's going to find this note and this note and this note, every one that's on the beat of the bar. This is a 4/4 beat. It matters in this case. This algorithm is specifically set up for a 4/4 time signature. This is another position sensitive preset, but this time we're operating on a bar range. So we're looking for specific locations within the context of a bar. And we have these things called pulses per quarter note. All of these numbers here refer to PPQ. And if we have a look in our preferences, The application pulses per quarter note base is 480. I don't want to get too far down this rabbit hole, but basically a pulse is a tick. There are 120 ticks in a 16th note. You can see that that's specified here, which means there are 480 ticks in 4/16 or 1/4 note, pulses per quarter note. It's the standard mechanism with which we describe music because the vast majority of Western music is in 4/4. Quarter notes are just basically the language that we talk in. What it means is that a 60 tick zone is a 30-second note. And here you can see I've specified zones inside this bar range box here. I can kind of click and drag in this zone, in this box, to make the zones as big as you like, and select notes on beat. So I've gone 60 ticks behind the beat and 60 ticks in front. Each of these 5 bar range conditions, we need 5 because there's half a one at the beginning and half a one at the end. If any of them are met, these are all OR conditions. If any of these 5 bar range conditions are met, then the entire condition is going to be satisfied. And so we're looking for notes inside these zone ranges to within a level of accuracy. Finally, we're looking for a specific note. So again, we're interested in F#1. And now when I click apply, the correct operation's being performed. And once again, I can move them down to the side stick. Now we've got a new drum beat. That sounds pretty good. So this is just basically different ways to flex your creativity, to throw stuff at the dartboard and see what sticks. That might not have sounded very good as a side stick. I might want to move it somewhere else, might want to try a different hi-hat articulation instead. It's perfectly within my wheelhouse to spend 5 minutes moving each of these notes up one step at a time. I bet the ride sounds decent. Yeah, there you go. All just interesting stuff, helping you to be creative, helping you to come up with new ideas. So yeah, I'm not going to lie, there are barriers to entry here. You need to understand a little bit of MIDI, you need to understand a little bit of logical processing. There are so many options in the logical editor, it's really difficult to just learn them all dry. You need to go into examples, see what's it doing with major thirds, find out what it's doing, see if you can use that in some sort of creative context. Hope you enjoyed the episode. Please hit like if you did. I'll see you next time. Thanks very much.